Hi everyone. So this video is meant to help you with factoring. I'm going to go over the notes from the first 5 ways to factor, and then we're going to end up doing the last way, which is the sum and difference of cubes. So go ahead and grab your notes. On your notes, the first thing you have to do always is check for GCF. Okay, so GCF is the greatest common factor. You first want to factor out anything that they have in common. Okay, no matter what type of factoring you're going to do, you're always going to check to see if they have a GCF, meaning are all of the terms divisible by the same number? Do they all have the same variables in common? So in the first example, we have 24x to the fourth minus 12x cubed plus 48x to the fifth power. Notice all of these numbers are divisible by 12. They're all divisible by 6, they're all divisible by 4, they're all divisible by 3, but it's called the greatest common factor because you want to divide by the biggest number. And here they're all divisible by 12. So you're going to factor that out, okay? So you take out the 12. Then you look at the x's. In the first one, you have x to the fourth power, x to the third power, x to the fifth power. So what they have in common, the most that you can take out of the x's is going to be x to the third power. They each have an x cubed to give. So 12x cubed becomes your GCF. If the question is, what is the GCF? The answer would be 12x cubed. Now, if we're going to actually factor, then what you're going to do is take out the GCF 12x cubed, and then you're going to open parentheses. So then you say 12 goes into 24 2 times. I used to have x to the fourth. I took x cubed out. I'm left with x. Remember that by the rules of exponents, when you divide, you subtract the powers. 12 goes into 12 one time. X cubed, I factored it out, so I don't have any x's left. You have to put the -1 here, or when you distribute to check to see if you did this correctly, that middle term of negative 12x cubed will never come back out if you don't put that -1. Then 12 goes into 48 4 times. I had x to the fourth. I took out x cubed. So I have x left. Sorry, I just realized this is supposed to be 48x to the fifth to match. So it was 48x to the fifth. You took 3 out. You have 2 left. Okay, difference of two squares. Difference of two squares is another type of factoring. You should be familiar with the perfect squares. So if you don't know the perfect squares, it's going to be harder for you to recognize when you have the difference of two squares. So it is called a square because 1 to the second power, 1 squared is 1, 2 squared is 4, 3 squared is 9, etc. Okay, so this goes 10 squared, 11 squared, 12 squared, 13 squared, etc. So the way you factor the difference of two squares is literally by taking the square root of both terms, 1 plus 1 minus. The fact that it's 1 plus 1 minus means that when you distribute, that middle part is going to cancel out, and therefore that's why it works. So if you take a look at the example, 4x squared minus 36y squared, they're both divisible by 4. So you first always look for GCF. Remember, that was the first thing we talked about in the first type of factoring. So here, because they're both divisible by 4, I go ahead and I factor out the 4. They do not have a variable in common, so the GCF is just 4. So now I'm left with x squared minus 9y squared. Okay? So x squared minus 9y squared, that is the difference of two squares. There's two terms. It is a binomial. X squared, the square root is x. 9y squared, the square root is 3y. The 4, because I'm factoring, just keeps on coming down. So this gets factored x plus 3y, x minus 3y. And it doesn't matter if you write x minus 3y first and then x plus 3y. It's exactly the same answer. Okay, so that's a difference of two squares. Now, there is no such thing as the sum of two squares. If you have x squared plus 100, this does not factor out as x plus 10 times x plus 10, okay? if you were to distribute x plus 10 times x plus 10, you are going to end up with a middle term of 20x. So again, if I were to distribute and I go x times x is x squared, x times 10 is 10x, 10 times x is 10x, and 10 times 10 is 100, you're going to end up with x squared plus 20x plus 100. That's not the same thing as x squared plus 100. So there's no such thing as the sum of two squares. This actually cannot be factored, x squared plus 100. We call this prime. When it cannot be factored, the word is prime, okay? When it cannot be factored, meaning nothing can come out. Because if this were, instead of x squared plus 100, 2x squared plus 200, notice I have a GCF. They're both divisible by 2. So I can first factor out the 2, and then I'm left with x squared plus 100. So I will not call this problem prime at all because of the fact that I actually factored out a 2. I did have a GCF from the very beginning of the problem. Now I can't keep going because x squared plus 100 cannot keep getting factored. So hopefully that makes sense. If you start with a problem that you can't do anything to it at all, no factoring at all, then it's called prime. Okay, you cannot factor. If you can even take out a GCF, then that's how you're factoring it. So you don't call it prime. But this only works for the difference of two squares. That's why it's called difference of two squares. Difference meaning subtraction. Okay, so that's the second type of factoring. The third type of factoring is factoring by grouping. I like factoring by grouping. I like all of them, you know. Because it's easy to tell that you have to factor by grouping. Notice that you have 4 terms. 1, 2, 3, 4. As always, scan it to see if in fact all of them have something in common. And they don't. It looks like they do, but they don't. So you see an A here, but not here. You see an X here and here, but not in the other one. So even though it looks like they have similar variables, they don't all have the same one. Because you have 4 terms, you're going to factor by grouping. You're going to group the first 2. You're going to group the last 2. So then what do? You find GCF, the greatest common factor from each group. From the first group, what they have in common is the letter A. So I'm going to take out the letter A, the variable, and I'm going to be left with x plus y. From the second group, what they have in common is the letter B. So I go plus, because of the plus in the middle, B times x plus y. So now you look at this and you're like, okay, what do they have in common now? They actually have x plus y in common, both of them, which is great. So what I'm going to do now is that I'm going to factor that out. I'm going to take out what they have in common. So this is going to equal x plus y. And then once I factor it out, notice I immediately open another parentheses and I write what I have left, which is a plus b. Some people do this backwards. Some people like to write the a plus b first and then the x plus y. It doesn't matter. It's the same answer. So that's how you factor by grouping. If you look at example 2, be careful with the minus because there is a minus in the middle. When I group the first 2 and I group the second 2, notice that I'm going to include that minus in my group. So from the first 2 here in my first group, what they have in common is an x. So I can go ahead, actually x squared, because this one's x cubed and this one is 2x squared. So I'm going to factor out x squared. And so I'm left with x plus 2. Then I come to the second group. They're both divisible by -3. I factor out -3 and I'm left with x plus 2. And some of you might be like, why are you left with x plus 2? There's a minus here. Yes, but -6 divided by -3 is +2. Okay, so when I grouped them, I included the minus, I factored it out, and that makes this positive. So now I am happy because I notice I have x plus 2 in common. So I'm going to pull that common factor out, x plus 2. And I'm left with x squared minus 3. X squared minus 3 is not a difference of two squares. If it were like x squared minus 9, x squared minus 4, x squared minus 25, I could have kept on going and factoring that out. But 3 is not a perfect square, so I'm done with the problem. So that's factoring by finding the GCF, the greatest common factor. The difference of two squares, we did factoring by grouping. The next two are trinomials. We have 3 terms. So there's 2 types of questions that have trinomials. One of them is when the leading coefficient is 1. Some of you are like, what is the leading coefficient? If you have something like 2x squared plus 28x plus 80, leading coefficient means the number that's in front of the variable with the highest power. So leading coefficient here is x squared because that's the highest power. C stands for a constant, any number by itself with no variable. So when all I have is a 1 in front, that means it's just x squared or y squared or whatever variable they give you. That means it's a leading coefficient of 1. So trinomial because there's 1, 2, 3 terms, trinomial. The difference of 2 squares, that these were binomials because there were 2 terms. In general, these are all called polynomials, FYI. Okay, so we take a look at the example, 2x squared plus 28x plus 80. Notice they're all even numbers. So absolutely, from the very beginning, I know that they have a GCF. They're all divisible by the number 2. I'm going to factor that out. So the first thing I'm going to do is factor out the 2. They don't all have an x. So I'm going to be left with x squared plus 14x, because 28 divided by 2 is 14, plus 40, because 80 divided by 2 is 40. So how do trinomials work? This trinomial has a leading coefficient of 1, which is great, because what I do now is check the back number and say what multiplies to give me positive 40 that's going to add to give me positive 14. Okay? So what's going to multiply to give me positive 40 is going to add to give me 14. And this is where you knowing your times tables actually comes into play. 1 multiplies to give me 40. 1 times 40, 2 times 20, 4 times 10, 5 times 8. Okay? So 40 is 1 times 40. Oh, I forgot that here on the paper. It's right here. 1 times 40, 2 times 20, 4 times 10, 5 times 8. But you're looking to see which of these combinations is going to add to give you 14. And the only one that does is 4 times 10. So I'm going to factor out x squared plus 14x plus 40 as x plus 4 times x plus 10. And then remember the 2 that I took out from the beginning, I basically just rewrite it. And you could write this as 2, and instead of putting x plus 2 first, I can put x plus 10 times x plus 4. That's the same answer. These are called factors. So that's exactly the same answer. Okay? Easy. So far, so good. Over to the back. We have x squared minus 5x minus 14. This is a trinomial. 1, 2, 3 terms. The leading coefficient is 1. The number in front of x squared is just 1. There's nothing there. And I don't have a GCF. They're not all divisible by the same number. They don't all have the same variable in common. So I'm ready to factor, or try to factor, because it is possible that it's prime, remember. Here it has to multiply to give me negative 14, and it has to add to give me negative 5. Okay, I'm sorry for my handwriting. I'm trying to do this with the mouse, and obviously it's not easy. Okay, so it has to multiply to give me negative 14 and add to give me negative 5. So then you have to think, what multiplies to give me 14? Well, it's 1 times 14, 2 times 7. Basically, that's it. So now you have to test combinations, pluses and minus. Is it a positive 1 times a negative 14? Is it a positive 2 times a negative 7? Negative 1 times positive 14. Negative 2 times positive 7. And because you want the 5 to be negative, you know it's going to have to be a positive 2 times a negative 7. So that means when I factor, it's going to be x plus 2 times x minus 7. And I can write this as x minus 7, x plus 2. What you can't mess up on are the signs. Okay, so these two things are the same, but you cannot say x plus 7, x minus 2. Do you know why? Because when you distribute, yes, this is going to give you negative 14 in the back, but this will give you positive 7, negative 2, and it'll give you a positive 5. And we don't want a positive 5, we want a negative 5. Okay, so this is going to be incorrect. So even though, yes, I can rewrite this a different way, I can't mess up the signs. Okay, so we did trinomials where the leading coefficient is 1. Now we're going to head on to what happens when I have trinomials where the leading coefficient is not 1. Okay, then what? Some people have taught this to you before as trial and error. Trial and error is literally you sit there and you open your parentheses and you try to see what will work, which combinations. Some people get really good at that and they kind of get these hunches and they try them out and they're like, oh, they found it. I'm not going to teach you that way because for other people, it's very frustrating because you can sit there for a long time and never figure out which combination works. So instead, I'm going to show you a different technique. When you have a trinomial and the leading coefficient is not 1, like in this example right here, 6x squared plus 11x minus 10. They don't have a GCF. They're not all divisible by 2 because 11 is odd. They're not all divisible by 5 or 3 or anything like that. And they don't all have a variable in common. So it's a trinomial, 1, 2, 3 terms, but the number in front of the x squared, which is the highest, exponent here, is not a 1, it's a 6. So what am I going to do? I'm going to take the 6 and I'm going to multiply by negative 10. I take the 6 and I multiply by negative 10. That gives me negative 60. Then I'm going to ask myself what multiplies to give me negative 60 that's going to add to give me positive 11. And this is where times tables are really important and being able to multiply. If you don't know, it's going to be 15 times 4. Okay, so 15 times 4 is going to give me 60 when I multiply. Remember, I want it to be negative, which means one of these has to be negative, but I'm going to check over here to find out which one. It has to add up to positive 11, which means the 15 has to be negative. The 15 has to be positive and the 4 has to be negative so that when I add these, I get a positive 11. If it were negative 11, it would be negative 15, positive 4. So again, trinomial, leading coefficient is not 1. I start by multiplying. 6 times negative 10 is negative 60. What multiplies to give me negative 60 is going to add to give me positive 11, positive 15, negative 4. What do I do with that? I'm going to rewrite the problem. I'm going to rewrite the problem as 6x squared, but instead of writing plus 11x, I'm going to break up the problem into what I just found. So I'm going to put plus 15x minus 4x minus 10. So what I'm doing is changing the way the problem looks. I haven't changed the value of the problem because 15x minus 4x are like terms, and if I combine them, I get 11x. So I haven't changed anything except the way it looks. It's like putting a new shirt on. You're still you, okay? So now I've done this so that I can factor by grouping. I have 4 terms. I'm going to group the first 2. I'm going to group the last 2. Be careful with that minus. Make sure you include it in the parentheses. And so 6x squared plus 15x, they're both divisible by 3, and they both have an x in common. So I take out 3x. 3 goes into 6 2 times. I had x squared, I took 1 out. I have 1 left, plus 3 goes into 15 5 times. I had 1x, I took 1 out. I have no x's left. Minus, because they're both going to be divisible by a negative number. I know that for sure because they're both minuses. So here, They're both divisible by -2. -2 goes into -4, 2x. -2 goes into -10, +5. And this makes me happy because I see that they have the same factor in common right here, which is awesome because that's exactly what I want to happen. So then this factors out as 2x plus 5. I take that out because that's what they both have in common. That's an ugly 5, sorry. So 2x plus 5 times 3x minus 2. Okay? And then that's your answer. And you can always check to see if you've done this correctly because you can distribute. Remember, factoring is the opposite of distributing. So if I actually sit here and I distribute and I multiply it out, I should get back exactly the same problem. So I'll get 6x squared minus 4x plus 15x minus 10. And what happens when I combine like terms? I end up with exactly the same problem, 6x squared plus 11x minus 10. So I'm literally back to where I wanted to be. Perfect. Okay. There's another one here for us to practice on. We're going to practice on that one really quickly. 2x squared plus 7x minus 4. It's a trinomial, 1, 2, 3 terms. You are going to look for GCF. I don't have one. So what I'm going to do is multiply. I take the 2 multiplied by -4. That gives me -8. Check to see what's going to multiply to give you -8. It's going to add to give you +7. That should be easy. It's got to be a +8, -1. That multiplies to give me -8. And 8 minus 1 is 7. I rewrite the problem. So 2x squared plus 8x minus 1x minus 4. So now I have 4 terms. I factor by grouping from the first group. They're both divisible by 2x. I'm left with x plus 4. From the second group, they're both divisible by -1. I'm left with x plus 4. Remember, -1 goes into -4 4 times. I factor out what they have in common, x plus 4, and I'm left with 2x minus 1. Voila, that's it. Okay, so the more you practice this, the better you're going to get at it for sure. So those are the first 5. The last one is the one that people practice the least because you don't really see it as often. There is a technique to this. It's one of those things that you have to just do it over and over again because it's not that difficult. You will get it, but obviously you're not used to even seeing perfect cubes. This is called the sum or difference of cubes. It works with addition and it works with subtraction, unlike the difference of squares. Because it's sum or difference of cubes, the first thing is you have to recognize the perfect cubes. Okay, so this is 1 to the 3rd power, 2 to the 3rd power, 3 to the 3rd power, 4 to the 3rd power. 5 cubed is 125. 6 cubed is 216. Because if you don't recognize it, you'll never know that you have a sum or difference of 2 cubes. So we're going to do example 1. Y cubed minus 64. The first thing you're going to do is that you're going to rewrite y cubed minus 64 as y cubed minus 4 cubed. That is so you see it and you're like, oh yeah, that's the difference of 2 cubes for sure. So when you factor out the difference or sum of 2 cubes, you're going to have a little parentheses and you're going to have a longer parentheses. Always? Yes, always. This is going to be a binomial. This will be a trinomial. So this is what you're going to do. You're going to ignore all the cubes in this part. Okay? You're going to ignore all the cubes. And you're going to write down just what you see, which is y minus 4. So in the first parentheses, that's always the easiest one because you just write down everything that you have, ignoring the cubes. So y minus 4. Then I'm going to work with the front and the back because it's easier. I had 1 y, but I'm sorry, I had 3 y's, but I took 1 out. So I'm left with y squared. I had 4 3's, 4 cubed. I took 1 out. So in the back, I have 4 squared left, which is 16. Okay, So I rewrote it. I wrote down exactly what you see without the cubes in my first parentheses. And then I dealt with the first because it's going to be y squared. And then the back is going to be 4 squared. That should be easy. Let's talk about the signs. There's going to be 2 signs. The first sign will always be opposite. If this is minus, this is plus. If this is plus, this is minus. And the last sign is always plus. Always. Always plus? Yes, always. Always plus. Okay. And then what goes in the middle? Y times 4, which is 4y. So the middle is 4y. So the answer to factor this is going to be y minus 4 times y squared plus 4y plus 16. This is actually pretty cool. I know that you guys don't like learning things like this because you're like, oh my gosh, it's so much to remember. Somebody had to realize that this actually works and prove that it works, no matter what type of sum and difference of cubes you have to do. So think about it. It's pretty cool. Okay, 125 plus 8x cubed. Let's do that one. So 125 plus 8x cubed. First thing you want to do is that you have to recognize, there's 2 of them. I have an x cubed. 125 is 5 cubed and 8 is 2 cubed. So I'm going to start by rewriting this as 5 to the 3rd power plus 2 to the 3rd power x to the 3rd power. Okay. So first I rewrite it so that I can see it with the cube part. So now remember, I told you, you're going to have a little parentheses and you're going to have a longer parentheses, binomial, trinomial. You're going to grab exactly what you see, ignoring the cubes, and that goes first. So I'm going to write this as 5 plus 2x. And again, forgive my handwriting. I'm using the mouse to do this. So then I had 5 cubed. So I'm going to have 5 squared left. 5 squared is 25. I had 2 cubed x cubed. So I'm going to be left with 2 squared x squared, which is 4x squared. The signs, this is plus. The first one is opposite, always plus. Multiply these together, 10x. And when you multiply these together, you don't care about the signs because you already took care of them. You just care about the number, 10x. That's it. Let's do x cubed, y cubed, minus 216. Okay. So I'm going to rewrite this. X cubed, y cubed, minus 6 to the 3rd power. I am going to open my parentheses, small one, longer one. Ignore the cubes, write down what you see. xy minus 6. I took out an x and a y, so I'm left with x squared, y squared. X squared, y squared. First sign is opposite. Multiply these together, 6xy. Last sign is always plus. I'm left with 6 squared. 6 squared is 36. So that's the answer. You can do it like this, or you can do it the way I've been showing you, which is obviously grab the xy minus 6. Do the front and the last first because it's easier. So you're left with x squared, y squared. And the back, you're left with 6 squared, which is positive 36. Opposite sign, always plus. Multiply these together, 6xy. Okay. So for your homework, I'm going to share some of the homework answers so that you can see them. X plus 3 times x plus 2, y plus 12, y plus 3, p minus 9 times p minus 3. In number 5, notice there was a negative in the front. Just take it out first, and then you can deal with it. So I'm going to show you the answer so that you can check your work. I love number 18 because you have to recognize there's a difference of 2 squares. You can't keep going here, but you can't keep going in the back because it's a difference of 2 squares. And then there's up to number 21. Try 22, 23, 24 on your own first, and then the answers will be posted on Teams. So hopefully this helps. Practice makes perfect. So just keep practicing. And I shall see you soon. Let me stop recording. Have a good one. Bye.